Hello students, again welcome to this lecture series. The topic that we were covering was number system arithmetics, and in the number system arithmetics, till now we have covered addition of binary numbers, and now we have covered addition of binary numbers, and left with you with some practice questions. I believe you people have completed these practice questions. Now in today's session we will start with addition of octal numbers. So octal numbers, you all of you just remember that octal numbers. Okay, so in this session, we will complete octal numbers. In this session, we will do addition of octal numbers, and octal numbers, you all know the symbols are 0 to 7, that is 8 symbols are there, fine, and 8 symbols are there. Hmm. And we saw that for doing any of the addition, we just need to know what are the addition rules of the particular number system. So let us first understand the rules of addition, right? So for this, for octal number system, okay, for octal number system, okay, we know that the digits will be 0 to 7. So if 0 is added with any of the digit, okay, with any of the digit from 0 to 7, the result will be the same digit, okay. And if any other two digits are added with each other, and like suppose 1 is added with 6, okay, and the result is less than 7, the result is less than or equal to 7, then the summation is done similar as we do in the decimal number system, like 1 plus 6 is 7, 2 like 2 and 3, 2 plus 3 is 5, right? So this is the rule that we follow. But where the difference comes when the summation of any two octal numbers is greater than 7. Let us see with one example. Suppose we want to add 4 as an octal number and 5 as an octal number. Okay, now the summation is like, if I convert it into decimal, it is 4 as a decimal, and it is 5 is 5 as a decimal, okay. Now if I add these two, what happens, this gives 9 in decimal, right? And 9 in decimal, we have to convert it into octal. In octal, we would write 8 and 1 9, okay, as, so the 1 in octal is equivalent to the 9 in decimal. So if I add 4 in octal with 5 in octal, so the result would be 1 in octal. It is not 9, because 9 is not a octal digit. 9 it is in decimal. Okay, now you have to convert it into octal. Fine. Suppose I take one more example, like if I add 3 and 7. Okay, now 3 and 7 in octals, they need to be added. Okay, now for adding them, you convert them first into decimal. 3 is decimal 3, 3 decimal 3, and 7 is decimal 7. Now when I add both of them, they are 10 in decimal. Okay, but 10 in decimal will be written as 8 and uh, uh, 8 and 2, uh, 8 and uh, 2. Okay, fine. So 10 in decimal will be written as 8 and 2, 10 in decimal, right? So this is 8, this is for 8, and this is for 2, 8 plus 2, 10. So 1, 2 in octal is equivalent to 10 in decimal, right? So let us take some examples. Right. So first example we will do 4372, and I add this 6 to 1 0. Okay. Now I want to add, both of them are octal numbers. Okay. Now if I do 2 plus 0, 2 plus 0 is, you have to use this rule. Okay. Now adding 0 to anything, the number will be same. Uh, then 7 plus 1. Okay, 7 plus 1 becomes 8. So it is greater than, greater than 7. Okay. So 8 will be written as 0 here and 1 carry. How I perform this? 7 in octal, 1 in octal, 7 is converted into decimal, it is 7, and 1 is converted into decimal, it is 1. 7 1 8, 8 in decimal, and if I convert 8 into, if I convert 8 into octal, then it is 1 0 in octal. Okay, so 0 is that, this 0, and 1 goes in the, this 1 goes to the carry. Okay, now 3 to 5 and 1 6. Okay, 6 is no problem, 6 and 4 are 10. Fine. So 10 10 10 10 10, we have done it. 10 10 in decimal. Okay, 10 in decimal is 1 2 in octal. Okay, so 2 will be here and 1 will go in the carry, and there are no digits, so this one is overflow. Okay, it is like same that happened in the binary system, where we understood this overflow bit. There was overflow bit, this is overflow digit. Okay, overflow digit. Fine. Okay, so the result is actually 12602 in octal, right? But if you have only 4 bits, 4 octal, 4 octal digits available, space for only 4 octal digits available, so this one will be discarded. But if I ask you that how many bits will be required to required to store this number. Okay, so some of you may give answer 5 bits are required. So I would say this is completely wrong answer. These are not 5 bits, these are 5 octal digits, right? And as you remember, each octal digit is equivalent to 3 bits. Fine. So total there are 5 octal digits. So 5 into 3, so 15. So it requires 15 bits to store, 15 bits to store this octal number. Fine. Let us do some more examples. One term that I want to add to you is that augend and addend. Okay, the number which is written here, like suppose I have written 4 4 3 2 6. Okay, and I write 2 6 3 1 and 5. Okay, if I write this number, this is an octal number and this is another octal number. So the number to which any number is added, the number to which any number is added is called an augend. Okay, the number to which any number is added is called an augend. Okay, and the number which is added to augend is called addend. Okay, so the upper number is called augend and the lower number is called addend. Fine, you should remember this term for your general knowledge purpose. Okay, now this is an example that we will solve. Okay, so 6 and 2 is 8. 8 8 in decimal, right? But in octal it is 1 0. So 0 will be in the lower side and 1 will be in the carry. Okay, 6 to 8 and 1 9. Okay, 9 in decimal, but in octal it would be written as 1 1. Okay, so 1 in here, and so how 9 is written as 1 1 in octal. Okay, 9 in decimal is written in 1 1 as octal. 8 is written as 10 in octal. You can prove this, right? You can prove this. The method that I told you, conversions. Okay, so that you can do. 10 in decimal is simply 8, and 2 10 in octal. Okay, and the maximum of two addition that you can get is 7 and 7. Okay, 7 plus 7, 7 in octal and 7 in octal. So that you will get 7 in decimal and 7 in decimal, right? 7 in, you will get 7 in decimal. So if you add 7 7, it is 14 in decimal, and 14 in decimal will be 8 and 6 14. Okay, 8 and 6 14 in octal. So 1 6 in octal. Okay, so this is how you will convert various carry related problems, right? So 3 3 6 and 1 7, no problem in this. Okay, 4 and 1 5, 5 and 4 is 9, 9 we will use this 1, and 1 goes to carry, and this carry comes here. So this number is the summation of this. You can also reverse check this. Hmm. How you will reverse check? You will first convert this number to, you will, sorry, you will first convert this number to decimal, then you will convert this number to decimal. Now you will add both of them in decimal, and then you will convert this number to octal, and this number has to be this number. Okay, so this is the method to reverse check. Okay, now I am writing some practice questions that you need to solve. Okay, first practice questions that I am giving to you is, uh, suppose this is first octal number, this is second octal number, and you find out the summation of both. Fine. Then I would do 6, 3, 2, 7, 1, and 1, 2, 6, 6, 7. Right. You do these two sums for your practice for addition of octal numbers. Okay, so addition of octal numbers is quite similar to binary numbers. The only thing you need to remember is when to go for the carry. Okay, and how to proceed for the carry. Where till you are less than, till the summation is less than 7, you have to do it like as you do it for your normal decimal numbers. But if the summation is more than 7, like it is happening here, okay, so what you have to do, you have to convert them individually into decimal, get the summation in the decimal, and then convert it into octal. So this will give you the first unit digit, the LSP give you the actual number here, and then the second LSB gives you the carry part. Okay, so this is how you are going to perform the addition of octal numbers. Okay, now we are shifting to next topic, that is addition of hexadecimal numbers. Okay, so hexadecimal, all of you remember it is 0 to 15, or you can say 0 to 9 and A to F. Okay, these are our 16 digits we use in hexadecimal numbers. Okay, so the rules are same. When you add uh, anything to zero, the number same zero, the number same is received. Okay, and if you go for any addition which is less than the summation is less than 15, so then there is no problem. You can do directly as you do in decimal. Like if you add 5 and plus 5, okay, 5 in hexadecimal and another 5 in hexadecimal, the result is 10 in hexadecimal, or we will not write 10, right? We cannot write 10, we will write it as a. Okay, a in hexadecimal. Okay, and it is quite similar that this decimal addition. But if the this you can do until your result is less than equal to 15. But now if you see that the result is more than 15, like in this case, 7 and a. Okay, 7 plus a, 7 in hexadecimal and a in hexadecimal. So what you have to do, you have to first convert it into decimal, right? And this is in decimal is 10. Okay, so 10 and 7 is 17 in decimal, right? And 17 decimal, you convert it into hexadecimal, you will write 16 and 1. Okay, so this is 16 and this is 1. 16 plus 1 is 17. Okay, so 17 is 1 in hexadecimal. Okay, let us take one more example. If you have a and if you have c, okay, you want to add these two digits, right? So directly you will not be able to calculate. Okay, first you convert it into decimal, right? This is in decimal is 10 and this is in decimal is 10, 11, 12. Okay, 12. Okay, the result of summation is 22. 22 in decimal. If you want to convert it into hexadecimal, this is 16 and how many of left 16. Okay, so 16 and 1 6 in hexadecimal gives you 1 6 in hexadecimal gives you 22 in decimal. Okay, so a plus c becomes 16 1 6 in hexadecimal. So 6 you will use as a digit and 1 will go to the carry. Okay, so uh, it is the same thing that we did here. These are the rules. Okay, so these are also the rules of addition. Okay, or hexadecimal, right? Okay, so let us have some examples with us. Mm, so I would say A15BF. Okay, and I want to add is 1 6 9 3 and 2. Okay, this I want to add. This is first hexadecimal number and this is second hexadecimal number. I want to add both of them. Okay, so f plus 2, f is for 15 plus 2 17. Okay, now either you have to do it in this way, that f is 15 in decimal and it is 2 in decimal, so that is 17 in decimal. Okay, that is 17 in decimal. Okay, now you want to convert it into something in hexadecimal, right? So what it will be, it is 16 plus 1 17. Okay, so what you will do, you will use this bit as the this digit as the result and this bit as the carry. Okay, now b is 11 and 3, 11 and 3 is 14 and plus 1 this 15. Okay, 15 is directly f, that you can write directly because the result is less than 15 or f. Fine, so 9 plus 5. 9 plus 5 is 14. 14 is simply E. That is less than 15. That is less than 15. So you can write it directly. Okay. 6 plus 1, 7. Okay. That is not a problem. A plus 1 is simply B. So this will give you the hexadecimal result of addition. Fine. So this is how you perform hexadecimal addition. Okay. So can you give the answer of this questions? How many bits are required to store this? If I ask you how many bits are required, how many bits? Now you can give answer easily. How many bits are required? Okay. So there are one, two, three, four, five, five hex hexadecimal digits are there. Okay, and you know that every hexadecimal digit has has required 4 bits. Okay, so there are 20 bits are required to store 20 bits are required to store this 5 digit hexadecimal number. Okay, so this is what we have to remember, that how many bits are required for a particular hexadecimal digit. These are digits of hexadecimal. These are not bits, right? This one is not a bit one. Okay, this is one as a hexadecimal digit. If you want to convert this in one into bits, this one in hexadecimal in the form of bits will be 0001. This you have to remember, right? This binary thing you have to remember. This is hexadecimal to binary conversion that we have done earlier. Fine, you can watch in previous videos. Okay, so let us have some examples for this. What we will take some augments and we will take some addends, right? Do you remember what are augment and addends? Yes, augments are the numbers to which some other number is added, and addends are the numbers which are added to the augments. Okay, so I will take augment as will take one example more. I will take it as F2B 3 and 7. Okay, and 9 9 2 7 5 and A. Okay, so this is our first hexadecimal number, or I can say this is our augend, and this is our addend. Okay, and I want to add both of them. Okay, what I will do, you have to do some fast calculations, right? And till you are not getting enough practice, then you can do the method like this. Okay, 7A. A is 10, and 10 plus 7 is 17. If you are not able to get directly what you will write for 17, don't write like this 7 and 1. No, 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 this is not a method to write. Okay, you cannot write A is 10, 7 is 7, and so 10 plus 7 is 17. So you cannot write 7 here and 1 here. No, this is the decimal addition, right? Yeah, this does not happens with hexadecimal addition. Okay, so A plus 7 is 17, but this 17 is in decimal. Okay, so you have to first convert it into 17 in decimal. You have to first convert it into hexadecimal. So that is 1 and 1. 1 is for 16 and plus 1 17. Okay, so this is 1 and this is 1. Okay, 1 goes to carry 5, 3, 8 and 1 9. No problem in this. B plus 7. B is 11. 7 is 11 plus 7 is 18. Okay, 18 in decimal, right? And in hexadecimal it would be 2. 1 2. Okay, so 2 will be used here and 1 will go to the carry. Then 2 plus 2 plus 1, oh sorry, 2 plus 2 plus 1. Okay, that is 5. No problem in this. F plus 9, that is 15 plus 9 is 24. So 24, you have 16 and you have 8. So that is 1 8. So 8 I will write here, 1 goes here, and this 1 is directly coming to the answer, and this goes to like this. Okay, so now I will write some practice questions that you can do by yourself, and check the answers from the online live calculators, online various converters that are available, and I have also shared the link in your Google Classroom, right? Okay, so first question that I would give to you is this. mm, 3 2 A B C 9 in hexadecimal, and you have 2 9 A B F 3. Okay, in hexadecimal. Now this addition you have to perform, and second addition that you have to perform is 3 3 6 B 9 A F C 2 9 A 8 and 3. Okay, this is first hexadecimal number, that is augend, and this is second hexadecimal, that is our addend. Okay, now you have to try these two questions, okay, for this particular addition of hexadecimal numbers. Okay, so this completes our addition of various number systems. First we saw addition of binary numbers, okay, that you have to remember these rules, and then we saw addition of octal numbers where you have to remember these rules. Whenever you have some confusion, direct convert into decimal, perform the result into decimal, perform the addition in decimal, and then you convert back it into the particular number system. Right now octal, so you convert it into octal. And if the number system, if the number system is hexadecimal, then you convert it into hexadecimal. Right, what we have done, you first convert the hexadecimal number into decimal, then you convert the second number into decimal, then you do the addition in decimal only, and then you convert it back to the hexadecimal. The practice, once you got the practice, then you will directly be able to get this direct number without following this conversion. Okay, so this conversion you have to do practice a lot, and I wish you all do good, stay safe during this corona epidemic, and be prepared for this. Be prepared for these topics with the help of these lectures only, because we never know when your classes will be resumed back. So I request you all to be prepared and regularly listen to the lectures and follow the assignments and submit all the assignments in time. You are also required to follow the swayam course, that you have the additional lecture videos that you can follow from the professor from IIT. Okay, thank you. I'll share you more videos soon. Okay, thank you.